Hey everyone, I'm Joshua Deemer and welcome back to Lesson 15 of our Java programming tutorial series. Let's jump right into the lesson. So here I have two classes, one named player. It has the basic information such as the username, X, Y, and health with a constructor and 4 getters. And the monster is very similar. They're both mobs. I use randomness to set the X and Y position. That's pretty much the only difference, plus there's no username. So let's go ahead and talk about interfaces real quick. So firstly, to create an interface, you would right-click where you want the interface to be, and you do a new interface. Okay? I'm going to just slap it into its own interfaces sub-package. And I'm gonna call this movable. Okay, so what I'm asking is, when I make this interface, and you'll notice it says public interface movable rather than public class movable, but what I ask myself is, what does this player have that would be easy to implement with abstraction? So an interface is completely abstract. Alright, and I'll show you what that means in a second. So what do we have inside of an interface? Well, we can have methods and variables. It's not too recommended to have variables, so like I could say int I equals 0. That's fine, but I wouldn't recommend it really that much. And you can have methods as well. However, the difference is that you're not going to be having curly braces with these methods. You're going to be putting semicolons. This is what the abstraction means. This method is not defined and it can't run on its own. It's abstract. You have to rely on other things to set this method. I'll show you what I mean in a second, but it's important to note that if you do create a variable, like this int I equals 0, by default, it is always going to make it public static final. So even if you leave out final, it's going to be final. If you leave out static, it's going to be static. If you leave out public, it's going to be public. In interfaces, variables are always public, static, and final. The same with methods. They're not static by default, but it is essentially saying public void method like this. Okay, except it's a semicolon because we're making it abstract in an interface. Okay, so saying void method is the same thing as saying public void method. Interfaces work differently from classes in this way. If I were to say private here, there is no issue because it's a class and we're making it private. But with an interface, everything is public. If I try to make this private, it'll actually throw an error. Okay, and so I need to make sure it's either public here or just straight up blank. Okay, so now how do we... Well, first, let's make it so that we have an actual valid method here. So if I type void move, and in here we'll have int x, int y. So for example, I want this to be abstract between the player and the monster. Okay, I want this to do different things according to if you're a player or a monster. Now I could just as easily say public void move like I have been before, but this makes it more abstract and to make a little more sense. So, and I'll show you why in a second. So if I go into main here, I could say movable item, we'll just say item equals new movable. You'll notice that this actually, well, if I import it, it'll actually not work because you can't initialize a movable because it doesn't know what to do with this move. I could type item.move and it'll pop up like this. But let's say I were to run this. There would be an issue here because move is not set to anything. So what you can actually do is you can add curly braces here and you could say public void move int x int y. This would make it so that there's no issue. So in here, you can say system.out.println x plus comma plus y. So now move is no longer abstract because we set it inside of a body for movable. If I run this, you'll see it prints 1010 because now move has no issue. So you can't just leave it as it is like this. You need to do something with this move inside of movable. So what we can do is we can say that a player implements a movable. Now you need to import it because it's in a different package. It's in a sub-package of mobs. But you'll notice that player has an error. If I hover over it, it says it must implement the inherited abstract method move. So if I click add unimplemented method, suddenly it's now inside of the class. We have at override, so it's overriding whatever this one is, which is nothing, it's just blank. So we're overriding it, and now move will work like this. If I say this.x plus equals x and this.y plus equals y, it'll work like normal. And so what I can do is if I say player equals new player, and we'll say the username's Joshua, we can say player.move 1010, and it'll work just like normal. However, because a player implements movable, we can actually store this inside of a movable player, like this. Because a player is a movable entity, or a movable mob. And so now, move still works perfectly fine, but it's a lot more abstract. We don't necessarily know that it's a player being created if we're outside of our main class here. And I can do the same thing here with monster. I can say it implements movable. Import it. And now I can add unimplemented methods and it overrides it again. So now I can have this move do something different. So for example, I could say this.x equals x rather than plus equals. So this move will be teleporting the monster. So what that allows me to do is if I say movable monster equals new monster, there's nothing in the constructor, import it. There's no errors, even though player and monster are two very different data types, they have one commonality, and that's a movable. So with player, I can now move it. However, since I stored it as a movable, I'm no longer to access like getX or getUsername, because those are all player dependent. So if I make this player now, you will now see that I can get the username, or get the X, or get the Y, whatever it is. But if I change this to movable, it'll only give me what's accessible inside of movable, which is just move, right? So now, if I say monster.move 1010, even though these are both under movable, and it's completely abstract, we know that player is actually going to do, oops, yeah, it leads to there, it leads to there. It'll actually add 10 to x and 10 to y, while monster, even though it leads to this movable, it'll equal 10 and 10, rather than adding them. They'll do their own separate things, even though they're technically both under the movable data type. Keep in mind, this is a much more advanced form of object-oriented programming. If you don't understand it quite yet, that's okay. I highly encourage you to play around with it so that you can get more familiar with it. Let's go ahead and create one more interface before continuing on. So I'm going to call this healable. And then in here, we're going to have a void, and it's going to be heal int amount. It's going to be abstract. So I don't want the monster to be healable. Okay, so I'm not going to actually make it implement healable. But player, I want to be healable. But there's a problem. We already have a interface that we're implementing. All you gotta do is say comma healable. Import it. And now there's no problem, except we need to implement our heal method that is abstract inside of healable. Okay, so in here we can say health plus equals amount, like we always have. Okay, and so now what we can say, instead of movable, we could say healable player. Gotta import it. And you'll notice that move now has an error because the data type healable doesn't have the method move, even though player does. But I can say player.heal 10. And notice that I cannot make the monster a healable because the monster does not implement healable. Okay? So make sure that you understand that. You can only make these data types similar to what they are implementing to or extending. And we haven't gone over extending just yet, but we will. But this is how interfaces work and how the abstractness can help make things a little more hidden in your code and a little harder to figure out. Now, casting isn't too terrible. I'll show you the simple form and then the more complex form. So the simple form is with primitive data types, okay? So here I said double A equals 97.0. In fact, I could say 97.7, okay? And then I say int B equals A, and then character C equals B, then I try to print it out, or print out C. And you can see that there's errors. That's because a double can't be converted to an integer because it's wondering what to do with this decimal point. You can technically make an integer into a double because all it does is add a 0.0 at the end and it knows what to do with that. But it doesn't know what to do with this decimal point at the end. This is where casting is very useful. If I have parentheses here and I say the data type I want to convert it to, I can say int inside of parentheses, and it'll take this 97 and basically it chops off the 0.7 into an integer, and then you can store it as an integer. You can do the same thing with a character. So if you convert it to a character with casting, it'll allow you to take an integer and turn it into a character. So 97.7 becomes 97, and it becomes, I believe, lowercase a. Yep, lowercase a, because 97 into a character in UTF-8, which is what Java uses by default, is a lowercase a. And that's how simple casting can be. In fact, what you can do is you can say double A equals 5.5, double B equals 4.5, 4.4, and let's say we do system.out.println a minus b. Okay, and we run it, we get nice old issue there, but it basically takes the doubles and subtracts them from each other. But what if I want to store the result in an integer? You got a minus b, right? So what I can do is I can say int here, and I int here, and it converts them both to an integer, perfectly fine. If I run this, you'll see we get 1. But I could also surround the entire thing by an integer, so that it can actually do the operation with its decimal points and then convert the result as an integer, rather than, okay, this is an integer, now this is an integer. See, what happened before was it's taking 5.5 and making it 5. Then it's taking 4.4 and making it 4. And then it does 5 minus 4. But what this does is it says, all right, what's 5.5 minus 4.4? Then take the integer of that. So that is a way that you can use casting as well. One more aspect is with our interfaces that we learned about. So let's say we have player equals new player, Joshua, and we import it. Okay? A player, as we know, is also a movable and a healable. So if we wanted to, we could say movable move equals player. Right? So we know for a fact that a player is a movable. But what we could also do is say player revert is equal to move. Now hold on a minute, this is red. Well, that's because you need to add a cast to a player. And now it'll work perfectly fine and revert it back to a player. Or what you can always do as well is, let's say you have created it and stored it as the interface data type. You can still do this and it'll revert it back to a player perfectly fine. So let's say we do system.out.println and we do revert.getUsername. We run it and it still says Joshua perfectly fine because in the memory we store it as a player, but in Java we understand it as a movable. And then we just reconvert it back to a player right here. Okay? What you could also do is, if you wanted to, you could say, after this, healable, heal equals revert. And then you could say player revert to equals a player of heal. Because a player is a healable, right? This will give us, if we change this to revert to, this will give us the same result. What you cannot do, however, so let's say we change this back to a movable. We'll just say move equals revert to, because move is already initialized up here. What you cannot do is, we know that monster is also a movable, right? If I were to do this, okay, actually, I'll just remove all the middle space. If I were to do this, and we have move equals a new player, there's no errors here, because a monster is a movable, and we're not really checking if a movable's a player or anything like that. So we can do monster.getX. Come on, there's no errors here. This will launch fine, but it'll say that it cannot convert a player to a monster. Okay, so even though a monster is a movable, if you initialize it as a player, it's not gonna work. But if you initialize it as a monster and run it, it'll work perfectly fine. Now, for enumerations, they make life quite a bit easier for a lot of things. So like if I go into monster here, how do we know what type of monster it is? Now, there's other ways to handle this, but for example, I'll do one of the simplest ways, private string type. Like you could have a string that says what type of monster it is, or you can use an enumeration. So what I'm going to do is I'm going to create a new enum, and I'm going to call this monster type. Okay, so we have public enum monster type. So inside of here, I'm going to add some names, and I'll just like copy Minecraft for this. Like for example, zombie. Okay, it's a constant, so it's all uppercase and snake case. So with underscores instead of spaces or whatever else. And then you separate them by commas. So like skeleton or creeper. Now, what I like to do is I like to have these on different lines like this. So this is an enumeration. You're saying that you want an enumeration of monster types, and it's between a zombie, a skeleton, or a creeper. Okay? Now you can have a semicolon at the end, but if this is all you're doing, you can omit it. You can leave it alone. If I go into monster now, what I can do instead is I can say private monster type. So what that means is the monster type can be only one of these three things. Okay? So if I go into here, and let's just make it public, make it a little bit easier so we don't need to make a bunch of code. So here I'm going to say monster equals new monster. import it, and we can say monster.type, and it's a monster type. Okay, so let's go ahead, monster.type, set it equal to a monster type, then we say dot, and you'll see creeper, skeleton, and zombie all show up there. So I can set the type like this also, and this is one of my more preferred ways. There is a better way that I think this could be handled, but for now we'll just go with enumerations. We'll go over the next type in the next episode. But this is one way that you can handle it. You can have a type zombie, or a type skeleton, or a type creeper. You cannot have any other type though, as it doesn't exist yet. And so over time you can add more, like a wither, a ender dragon, sort of thing. And you can add more over time. And so that's how this works. What you can also do, I'm actually going to keep that monster type dot, we'll say zombie. And so enumerations are also some of the things that can be passed into a switch statement. So if we say monster.type inside of here, what we can do is say case monster type dot zombie. Like this, so that we check. Hold up. Yeah, it's missing cases. What's wrong here? Right, so you don't need the monster type, you just say zombie instead. And so if the case is a zombie, then do something. If the case is a skeleton, then do something else. If the case is a creeper, then do something else entirely as well. Otherwise, if none of them are there, then we can throw new exception, where the exception is not yet implemented. We don't yet have something there, sort of thing. Okay, like we can do something like this, and then in order to do that I need to say that it throws an exception, which is something entirely different. But you'll notice that when this is missing, this is yellow underline. That's because we'll either need a default case or add the missing case statements like creeper. Okay, so you can use this in switch statements. You can obviously say if monster type is equal to monster type dot zombie. You can also do something like this. That's not a huge deal either. Now, something else to discuss is you can actually convert these to integers. So for example, if I were to say int type is equal to int monster.type, there would be no, oh, there is an issue. Oh, that's right. Because you don't cast it, you just say ordinal. Okay, this gets the integer value associated with the type. So if I were to print this out, so system.out.println type, and I run this, you'll see that it prints out 0. If I say skeleton, you can see that it prints out 1. If I say creeper, you can see that it prints out 2. That's because it goes in the order that it has it here. So what you can actually do is you can say if the type is greater than or equal to 1. So that would cover 2 different types rather than saying type monster.type is equal to monster type dot skeleton, or monster type is equal to monster dot type dot creeper. So this is a lot more long, and it does make more sense to the human mind, but this is much easier to figure out and a lot less typing to do. So you can do it in this way. You can also retrieve a certain monster type. So you can say monster.type is equal to monster type. It has default static methods such as value of, values, or value of and something a little more complicated. But you could say values, and this gives you the array of all the monster values. So you could say 1. And so what that will give you is skeleton, because that's what 1 is. So if I were to say that, and I were to print it out, println monster.type.name, so get the name of it, which is basically, where is monster type? Basically this. Okay, it's zombie or skeleton, all caps. So the first one is skeleton. If we say 2, it'll say creeper. If we say 0, it'll say zombie. But if we say 3, it'll be array index out of bounds exception because there's only 3 items inside of our enumeration. So you can also get a monster type by name. So if I say value of and I say zombie, it will actually get the zombie value and convert it into the enumeration for us. If I were to say lowercase zombie though, it will throw an illegal argument exception and crash our program. So you'll need a try catch, or if you know for a fact it's going to run perfectly fine, you don't need the try catch then. Enumerations can also be used like a class, so if I add a semicolon at the end here, and I press enter twice, I can actually start treating this like a class. I can say private monster type and have a constructor here. I can't make it public because an enumeration has constants and they cannot change, so you can't just say new monster type. But you can make it private or you can make it just package based. And then above here, you can say something like private string actual name, and you can treat it like this as well here, so actual name. But you'll see that you'll get errors up here because it doesn't know what to use for its constructor. So let's go ahead and say this.actual name equals actual name. Then we'll add a getter, public string get actual name, return actual name. So now what you'll want to do is you'll want to add parentheses here and then fill out the constructor. So we're going to put the actual name in here. So zombie, skeleton, and creeper. Then you can do more along those lines, say int max health. So the different max healths for them all. So private int max health. And you can say this dot max health equals max health. And you can do things along these lines as well. So private int get max health, return max health. So then you would also need to say 20, 10, 40. Okay, so you need to make sure that you add parentheses that match your constructor. If you don't have anything, then you don't need to have these parentheses. The enumeration works like that. Okay, so now when we go to our main and say we have monster type of zombie, instead of doing .name, which will print out zombie for us, we could just simply say .get actual name, which is something that we made. We got get actual name, and it should print out zombie like this. And it does. So we can also say get max health, because max health is also set, which is 20. And so inside of monster, you can do something is equal to the type that is set dot get max health, right? And then in here, obviously, you would want to do something like monster type, and you would say this dot type equals type, and you can continue like that. And then obviously fill it out here, monster type dot zombie. Right, so now you got the max health affecting it through the enumeration based on different monster types. So this is another usage that you can have for enumerations. Okay, now that we're aware of how both interfaces and enumerations work, let's go ahead and do a real example of this. So first, I want you to create the main method inside of a main class and a car class. Then create an enumeration for the car make. After that, populate the enumeration with different car makes you want. Probably 3 or 4 is fine, but you can do more if you'd like. Then make the car refuelable and drivable, and create new cars using casting between the refuelable and drivable interfaces and the car. Okay, I'm gonna go to black and we'll begin with this immediately. So if you want to do this on your own, feel free. Otherwise, we're gonna get started right here. So I'm gonna create my main method. I'll sort it through me.joshua.src, and then we can put the public static void main in there. Cool, so we got our main class. Now let's go ahead and create our car class. Now I'm going to also make not a class, I want to make enumeration of car make. Not cat make, car make. Rename file to car make. Okay. So now let's say we've got Toyota, GMC, and Honda. Okay. So we got our enumeration for cars. All right. Inside of here, we're gonna want our car make. Private string model. Private int fuel. Okay, cool. So what we could also do is do something along the lines of saying private car make int max tank, right? And so we could say private int max tank, this dot max tank equals max tank, public int get max tank size. Forgot my semicolon up above. Okay, so now inside of parentheses up here, I could say something like a Toyota has an 8-gallon tank, GMC has a 12-gallon tank, and Honda has a 16-gallon. We can do things like that so that the different car makes have a different tank size. And so now here we could also that'll just be part of car make. So we have private int fuel. That's all I'm going to do for now. So I'm going to say public car, and we'll say that we want to pass in the car make and the model. So now we say this dot make, oops, is equal to make. This dot model equals model. Then fuel is equal to make dot get max tank size. Okay, that's all set. So now we just need public car make, get make, return make, public string get model, return model, and then public int get fuel, return fuel. Awesome, so we got that all set up. Now what we need to do is we need to make the car refuelable and drivable. So let's make two interfaces. So refuelable and drivable. Okay, so in here we're going to say void refuel, and just like that, nothing inside. And then we're gonna have drivable void drive int miles, like that. So now that we have our two interfaces, let's make, not the car make, but let's in the car say implements refuelable and drivable. Now all we need to do is add the unimplemented methods. And so now we have refuel and drive. So if we're going to refuel, I'm going to say fuel is equal to make.get max tank size. In fact, I'm going to be a little extra and say public int get miles per gallon. Return MPG. Private int MPG. And we're going to pass in int MPG. This.mpg equals MPG. So now here, Toyota will say it's a nice old hybrid, which is 50 miles a gallon. And GMC will say it's a massive truck with 15 miles a gallon. A Honda, we'll say it's a minivan with 20. Okay, so now we got our MPGs all set up. So now what we can do is actually we can do a calculation inside of this drive because our make now has a miles per gallon. Hopefully I do it right. Kind of doing this on the spot. So let's say int gallons is equal to make.get miles per gallon, right? And then I believe it's miles divided by miles per gallon. And we know that since they're integers, it's not really going to work too terribly hot because it'll be an integer divided by an integer, and so its result will be an integer. So what we can do is we can turn one of these into a double by casting it. So I'll say double. So now it's an integer divided by a double, which will give us a proper decimal number. Then I'm going to say math.ceiling so that it rounds up. And then we'll turn it into an integer. Okay, so this math.ceiling, all it does is it makes this calculation round up. Okay, always. So even if it's 2.1, it becomes 3. So that way, if it becomes like 0.6, we're still making it 1 gallon being used. Okay? So now we got our gallons. So now we can say fuel minus equals gallons. We can also say something like system.out.println. You used fuel gallons going miles. And then system.out.println. You refueled to plus, then it would be make.get max tank size gallons. Okay, so now we've got everything implemented. Now it's just calling it inside of main. So now what we can say is something like car equals a new car, right? But in here we need our car make, so we can do car make dot, and now we've got our 3 options. Makes it real easy to take care of. So I'll just do a Toyota, and we'll say a Corolla. Just real simple. Then we can say car.drive, and we'll say 60. And car.refuel, and if we run it, it should say you use 6 gallons going 60 miles. Well, that's not correct. But you refueled to 8 gallons. That one's correct because it is 8 max gallon. And it should be 50, so 60 divided by 50, or sorry, 6 divided by 50. So let's do this calculation really quick. Yeah, so it should be 60, so 60 is being passed into miles, so 60 divided by 50 should be 2. For some reason, it's giving us 6. So what we're going to do is we're going to say system.out.println. We're going to do some actual debugging. .get miles per gallon. So now if I run this, it should say 60 and 50. So then what's the result of 60 divided by 50? It's 1. Okay. Oh, I see. I used the wrong variable. This should be gallons. So now it should say 2 gallons. Okay, now it's working fine. It was working fine because this was doing everything proper, but it was doing 8 minus 2, which is 6, and that's why it was saying 6. Because I printed out the fuel instead. Got a little bit of debugging this time, huh? So, yeah, that's pretty much everything, except for we can simply say something like refuelable, right? And this would work for refuel, but it would not work for drive. So if we wanted to, we could say drivable. Drive is equal to, and then we convert this to a car. So if we say car, then we can say drive.drive. Because the car is a drivable, so we don't need to explicitly cast that. So if we run this, it'll still run the same exact thing. That's the end of this episode. Next episode will be the final episode for tutorials. We still have one more project, and I would like to go over the Java Foundations certification exam as well. As for the next episode, we will be covering abstraction and inheritance in Java. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!